Welcome to Uncle Hippie Channel, Electronics Made Easy series. Today is episode EME 114, and we're going to talk about digital circuits and digital numbering systems. We're going to start with the binary numbering system, and then we're going to move on to logic gates. Let's start with why do we even need a binary counting system? The reason is computers are digital in nature, and digital means it's either on or off. So it's 0 is off, 1 is on. Therefore, ones and zeros are the only way that we can compute things inside a digital world, or a computer or AI. The next logical question is, how do we count using zeros and ones? Actually, it's a lot simpler than you think. All we do is skip everything that has the number 2 through 9 in it. Let's get some terminology out of the way before we start actually counting in binary coded decimal. So you may hear me refer to this as in two different ways. I may call it binary, I may call it BCD. BCD stands for Binary Coded Decimal. The next term is bit, B-I-T, and that is the smallest unit that a computer can store or process. It is a single signal. It is either on or off. That is what a bit is. And we're going to start with a 4-bit count, mostly to keep it simple, so it's easy for you to understand. We can count in 4 bits, we can count in 8 bits, 16, 32 bits. We seldom go above 32, but there is a 64-bit. That goes into huge numbers though. So let's start with the 4-bit word. There is one major difference between counting in decimal and counting in binary, or BCD. In decimal, you can start with the number 0 and just write one digit down as 0. In binary, however, if we're dealing with a 4-bit word, then we have to write all 4 of the numbers, as in 0 is actually 4 zeros, 0, 0, 0, 0. And that is equal to 0. If it were 8 bits, it would be 8 zeros and so forth. Let's start counting. We'll start with the number 0. As I said, that's 4 zeros, 0, 0, 0, 0. The next number, of course, will be 1. So it's going to be 0, 0, 0, 1. Now, if we skip the numbers 2 through 9, the next available number is 0, 0, 1, 0, or 10. Remember, we can only use ones and zeros. So if it has 2 through 9 in it, we can't use that number. So we go from 1 to 10. The next number would be 0, 0, 1, 1. Because it's the next number that has zeros and ones. The number after that is 0, 1, 0, 0, or 100, because everything else in between has the numbers 2 through 9 in it. So the next one would be 0, 1, 0, 1, or 101. The next one would be 0, 1, 1, 0, or 110, because that's the next number that doesn't have a 2 through 9. The next one would be 0, 1, 1, 1, or 111, and so on and so on. Okay, now we understand the basics in how to count in binary. So now we've got to figure out how to interpret the binary. What do those ones and zeros mean? Let's start by learning how we can convert binary to decimal. In other words, we're going to go from zeros and ones to zeros through nines. And we will start by creating a little table that will help us interpret that. Since we're using a 4-bit word, let's start with that in the transition from BCD to decimal. We're going to start with 4 numbers at the top. We're going to start on the right-hand side, moving to the left, and we're going to start with the number 1. And we're going to double it for each block, so it'll be 1, 2, 4, and 8. Those are the 4 numbers that we're going to use for this particular conversion. Again, this is pretty simple. It's not that hard to understand how to do the conversions. If you have a 0, you do not count the number at the top of that column. If there is a 1, you do count that number at the column, and all you do is you take all of the ones that you count, all of the ones that have 1s under them, and you add them together. That will give you the decimal equivalent of the binary number. Let's start with let's do a couple of demonstrations of how this works.